People do tell me often that I scare them somewhat by talking about infections as drivers of aging processes, which they absolutely do drive inflammation, epigenetic changes that are definitely not ideal as you age. But to me, what is far scarier is an epidemic of chronic disease that we're currently in, where the incidence of most chronic conditions is going up and kids are getting sicker with diseases at an earlier age. People are truly in poor health. Many people are taking at least one prescription medication, if not multiple prescription medications. Right now, we're definitely not on the right track. Really, the paradigms on which we're basing chronic disease, the models and the root cause drivers that we're thinking are happening, and the treatments, which are largely Band-Aids, are not working.
Hi, everyone. Welcome to Foresight's Existential Hope podcast. I'm so delighted today to be here with Amy Proal. Amy, I think we both met online for the first time in one of our kind of like during COVID. We had this standing Zoom room twice a day to cover the US time zones and Europe time zones that was trying to organize people around the question of what's actually happening right now as COVID started to kick off. And so we invited lots of folks that had a different lens to share on the pandemic as it was evolving. And that was the first time when I really got to know you and your work. And you were such an incredibly illuminating voice into trying to bring some light into the dark there. And then, of course, later on, our broader scope at Foresight in the biotech space is mostly aging and longevity related. And then, of course, turned out much of the things that you had to say were also deeply connected to that entire focus that we have. So I'm really delighted to have you here on the Existential Hope podcast, where we're also trying to generally investigate your philosophy a little bit and how you think about your kind of unique approach to health and what we might learn from that for building better, more resilient, more healthy futures for humanity. So thanks a lot for coming on. And maybe just start us out for those that might not be familiar with your work. What is it that you do at PolyBio and how did you get about to doing that? Because I understand you had a pretty unique history in getting to do the work that you do.
Sure. So yes, I'm a microbiologist, which means that I'm actually just a huge nerd when it comes to understanding how different infections, so bacterial infections, viral infections, parasite infections, can drive different forms of chronic disease. And there's many mechanisms by which they can do that. And so what I primarily do is lead a nonprofit research organization that I co-founded called PolyBio Research Foundation. And what we do is bring groups together who are at different academic sites or even different companies and pull them together into collaborative research projects to study and innovate how infections can contribute to a range of chronic disease processes. And as part of doing that, the story of what got me there is I was a pre-med college student and I was doing very well. And then I got an infection and I did not do well after this infection. This was at the end of my college time and I got really sick afterwards. And so I went to the student health center and I mean, it's a typical story that you'll hear actually from millions of people if you actually start to get out into the world of what we call infection-associated chronic disease, where I went and asked why I might have symptoms after this infection, and not only did no one have any answers or no diagnostic test to even know what infection I had gotten, which is pretty sad and something we're trying to fix for, but they didn't even believe me, okay? So it was this ridiculous path where I was sent to psychiatrists who tried to analyze and it was so clearly broken to me early on when I felt sick that as soon as I started, and it's a long story, I'll just skip that part. I started to do some experimental treatments and some antibiotics, antivirals, other supplements to support immune function that I basically helped kind of create on my own. And as I did,
how did you go about that? I guess it was before the time of ChatGPT, et cetera. Were you just like out there on the internet and subreddits?
Yes, very much. That's where there would be literally people online who would have thoughts and they treated common symptoms. But what I really did was go back to the literature. So in the 1950s, 60s, there were some groups who did incredible work on infections and what they're capable of doing, especially even bacteria. So there were teams, and these were, picture your classic lab, like a person in a white coat with a microscope. They were there, they'd isolate bacteria in petri dishes, and they'd be looking at what they were capable of. And they really documented already just with bacteria alone, truly interesting phenomena where, for example, a bacteria could lose its cell wall in a way that would make it practically invisible to the immune system, and where it could remain in an animal's body or in a person's body in a chronic state that was totally very different than what it was doing when it was a regular acute infection. And they would be able to show that normal tests don't pick this up at all. So that resonated with me because I was like, look, normal tests aren't picking up what I might have. And so those papers, which sometimes I still go back to because they have beautiful images of these infections and all kinds of really good techniques, were really inspiring for me to at least understand the capacity of a lot of organisms to be able to change their activity and change the way that they even manipulate our immune systems, or even the way our human genes can function to be able to persist in our bodies. And that was part of just looking through this literature that inspired me to gain ideas for what I would even try to do in terms of stuff to myself.
So why do you think it's still so under the surface?
It's a very good question. One of the key factors is that even with those earlier researchers who were really on the right track, the theory of autoimmunity got in the way of a lot of that work, because the theory of autoimmunity, which gained more recognition somewhat around the 70s, 1970s, it's simpler, it's less messy, it's easier to run with, which is all of these infections, these organisms, that's messy, that's hard to find. We have to study tissue. It can be different in different people. There's a lot of different complexities here. What if the immune system just screws up and it's the immune system's fault? And that model was really gained hold because what happens is, if you think that the immune system is just kind of, screwing up or targeting self, then you can bring in treatments that immunosuppress a person. So you can bring in drugs that knock down parts of the immune system and that, if you will, palliate a person's symptoms, right? So they might not, depends on what you know about these conditions, they don't get at the root cause, not if you ask me, but they make people feel better, at least somewhat, and at least for some period of time, by just shutting down the immune system. And when the immune system can't actually be as active and fire and figure out what's there, people will sometimes feel palliatively better for a while. So that's where immunosuppressive drugs started to come into the space, and those really took off with pharma. So even today, for a lot of conditions, blunt immunosuppression is the standard of care. So, and the drugs, I think Humira, for example, is an immunosuppressive drug that's used in a number of different chronic conditions. I can't keep track of the price, but it is not cheap. It's, I think, something like $30,000 a year. So you have these blockbuster immunosuppressive drugs that you can put people on. They feel a little bit better for a bit. But the sad truth is that because, at least in my opinion, you're not targeting root cause, the person actually, a few years down the road, needs a higher dose of that immunosuppressive drug, or needs
That's
a second
not a problem for pharma,
immunosuppressive drug,
though.
which, and not to be super conspiratorial at pharma, but it's not a problem where you have a clear market and people need more of the drug and they stay on the drug over their lives. It just doesn't incentivize pharma or even other bodies to really say, well, let's stop that whole paradigm and look for some other kind of root cause. So the theory of autoimmunity was a block to the study of persistent infection across chronic disease, which is...
So there you were looking for an alternative path. And what did you ultimately uncover?
Yeah, I mean, in my case, I think that there are some infections, basically tick-borne, like vector-borne infection. So eventually Babesia, which is a parasite that can be carried by ticks. It seems like I had some issues with that. And so I ended up treating bacterial infection in my case. That seemed to help. But as part of that, I became interested in far many other different types of infections and what they could also do in a chronic capacity.
Wow, so it's basically like you uncovered one tiny bit, because then you pulled on that thread and it unraveled this entire...
exactly.
So can you share more about, through that research, or like through your, I guess like personal digging, what's the larger kind of ecosystem of potential causes that you uncovered?
Well, then as I started to figure out that I really did think that infections were playing into many more people's cases, there's the biggest issue in trying to study that, document that, and diagnose it is that, let's say you get an infection and it stays in your body and it persists in your tissues or in your nerves. It's really hard. It's a hard thing to study and show to be true because the majority of our blood tests just take someone, draw blood from their arm, run it through some tests, and hope that whatever matters in this disease or in this person's chronic situation is in that vial of blood. And persistent infections, so viruses or bacteria or parasites, it is dumb if you're going to persist in someone's body to just float around in their blood. If you did that, you will be easily recognized by the immune system, where there's a bunch of immune cells also floating around in the blood who are going to recognize you and try to target you. So what the majority of pathogens do is if they're going to persist in someone's body, they hide in their tissue. So they start to get into even the deep tissue of someone's body, into their nerves, right? Into the central nervous system, into the brain, maybe even the spinal cord. And that's a huge challenge because you can't then find them with an easy blood test at all. And key is that you really have to set up an infrastructure, which takes a lot of time and money, to be able to understand what that infection is doing in someone's tissue, in their brain, and in their nervous system. So when we created PolyBio as a foundation, which we did around 2018, we wanted to help groups build the infrastructure to do that because it wasn't happening too much. I mean, here and there, people are doing it, but we wanted to accelerate that. And so what we did as a program is there's kind of two cool approaches. There's several that you can do there, which is you can get tissue from people via biopsy procedures, and you can analyze, you can set up more tissue banks. So you can get gut tissue via endoscopy. You can do a fine lymph node biopsy to get parts of the lymph nodes, which are really hubs of where the infections and immune system are doing a lot in a disease. You can get different types of tissue samples. And another thing that we started to think about was, look, there are people who are undergoing surgeries, routine or just surgeries that they have to do. So for example, let's say women with endometriosis, which is a condition that we are actively studying as having infectious components to it. A lot of women with endometriosis, sadly, because there's terrible diagnostics and few treatments for endometriosis, really one of their few options is surgery. So they go to a surgeon and they cut out parts of the tissue with endometriosis that is growing outside of where it should, outside of the uterus, with lesions that are very painful. And usually what the surgeon does is just clip those tissue samples out and throw them in the trash. And we basically started, and especially I did, a huge effort to contact surgeons who were engaged and to say, do not throw that out. Don't throw that sample in the trash. Just hold on. We're going to send you tubes with the preservation solution. We're going to help you, just instead of throwing it out, put it in this tube for us and capture it. And so we've worked with surgeons who are doing various kinds of procedures. In some patients, even people who undergo surgeries that involve the central nervous system. And we're getting tissue types in some studies that have never been analyzed from a living human person before, including one study, which is one of my favorites, that we're still in the earlier stages of, but it's a team who has surgeons that can get tissue from the vagus nerve, which is a really important nerve that connects the body and the brain and is responsible for some of the most important signaling between the body and the brain, from people who unfortunately experience a trauma and pass away in a hospital. But as soon as that sadly occurs, they're able to get parts of the vagus nerve, again, which has rarely been collected from human people early, preserve that. And we're currently working on the first ever study to characterize the microbes, viruses, and other organisms that might actually be in that nerve, which no one has bothered to check on yet, right? So we set up a pipeline of a lot of these different tissue collection studies that are allowing us to see. And it's pretty interesting because we just simply don't even know, for example, if viruses and bacteria might be in these different tissue types. So that's part of what we were looking at in our early capacity. And then we combine that with a lot of high resolution type imaging studies. So for example, there's a group at UCSF, University of California, San Francisco, who I think is so on point with the work that they're doing, where they can take a person, put them in a full body imaging scanner, and then take something like a monoclonal antibody, or let's say even an antiviral, tag it with something that will fluoresce if it binds. They can inject this into a person's body, and let's say they have a virus in their inner tissue. If that antiviral sort of recognizes that, they can tag it with a little fluorescent thing safely so that the camera and the scanner can note it and map basically in the scanner like a map of where the virus is throughout their body and brain. So kind of pushing the boundary on what technology can do with different methods to be able to understand these infections that might be in harder to find areas. And that's the basis of a lot of what we're doing at PolyBio. Sometimes I say our slogan is the issue is in tissue. And that's true. That's what we spend a lot of our time thinking about.
How many tissue samples do you guys have?
It's a good question. I think we were adding them up. I think at least 12 or 13 different tissue types that are rarely studied, and a growing number more. So a good number.
And once you got going on this, were there any, I don't know, I guess institutional drawbacks or setbacks? Is it just easy to contact someone and be like, hey, don't throw this in the trash. Just consider putting this in a tube and sending it to us. Were there any institutional hurdles at doing it? Or why hasn't it been done earlier? What's the reason why people haven't really been treating them as these like very precious probes that
I know. It's a really good question. I do think that part of it is just because it is hard to gain the permissions to get those samples. I understand that you have your ethics review committees, the IRBs, at different universities or hospitals where people are getting samples. And of course, they need to make sure that you're not going to do some kind of crazy biopsy on a person. Of course they do. But in this world of academic settings, which is where a lot of this happens, the review time, because this is a committee thinking about a type of tissue or a type of biopsy that's never happened before, we've had situations where just the review to decide if it's okay to collect that tissue has taken almost a year. And it's just painful. So you have to be very patient, very persistent. Also, it's hard with surgeons. They have people coming in and out. You have to find the right surgeon, someone who cares about the research, because it's it's some extra time to get the tube, to put it there, to make sure you have the storage. Sometimes we have to actually have dry ice or something that's more available. You have to go a little bit further than you usually would. And I think the thing is that in academia, where a lot of this is happening, everything is so structured to not innovate that way. Because most people in academia what they're doing is going in a stepwise process to get government grants. So they're trying to get grants from basically the NIH, right? And the way I realized that works is that you start off as a student, you study one thing, really. Very few people study a big picture problem. You end up specializing pretty early. So for example, you study T cells, and then you study T cells and their receptors, and then you study T cells and their XYZ receptor, and you get an early grant to study that specific thing, and then you do the work and you show something maybe a slightly new there. And then in your next grant, you need that data from the previous grant to be able to apply for a grant where you can go like one minute step farther than the other grant, okay? Where you can take it up one slight notch. If you even go a little farther than that, the reviewers it's just really hard. So you have these people who are doing very specialized things in this incredibly, and it can work, but slow, stepwise fashion. And if you reach out to that person and say, hey, you should pivot. What about collecting tissue and going over there? It's just hard because it doesn't fit into the infrastructure, the grant process, a lot of what happens to be able to just move things in the typical academic setting. So really what you have to do is go get non-government funds. That's part of it too.
Yeah, I mean, even just the collection part, like, I mean, this is kind of tangential related, but I recently gave birth and I wanted to bank the cord. And so basically what you have to do there is I had to research private companies that do that. They weren't allowed to give me any recommendations that work well in the Bay Area. Then you have to contact them. They send you the kit to your house. You have to then bring it when you give birth. So you have to remember that, then give it to your doctor, instruct them what you want them to do. And there's so much turnover, right? Especially if you have a longer birth, that like you need to instruct them over and over again as you're already like deep in the birthing process. Like just remind them, please do this. Then for us, they had banked they had kind of banked too much, but we had only paid for a smaller sample. So then there was a big question of what they're going to do with the sample now. And then the next day, you immediately, my partner had to do that in that case because I was not capable to do it, call the company to come to the hospital and pick it up. So it was this really kind of like weird, very weird interaction choreography between different people having to remember to do things at different times. And I really just wish there had just been a better pipeline, because these things are obviously also like interesting from a scientific perspective to keep, and often that stuff also gets thrown out. So it was just like one lens into, wow, that kind of process of like keeping some of the possibly quite valuable tissue samples that you could be collecting is not really like super well thought out, but it's more like a
Definitely. You
spontaneous
just
thing.
described what I do, which is say, hey, what about collecting this? And then end up going through all these hoops and loops, and you got to talk to this person. You have to get that permission. That person has to get that permission. And this person needs that person's permission. And yeah, it takes a while to be able to streamline that. And in some cases, even almost begin from scratch and start an infrastructure that's makes sense and agile, right? So that is part of what we work on.
Yeah, so maybe let's get back to, so you have all these, I guess, tissue banks.
Yeah.
And if basically, let's say that you uncover that there has been a cause that is slightly different to the cause that is traditionally assigned to a specific condition, then can patients or people that like are working with you or trying to use the services, or the people that you're trying to serve, can they just expect a better treatment, or is it pretty piecemeal on a case by case basis then what needs to happen? Because I'm assuming it's just not really like a one size fits all or a treatment that you prescribe, right? Or that you help
Definitely
to uncover.
And we're not even totally at that stage yet. What we're doing this for at this point is basically just to get the data out in scientific papers. So we're not even giving at the stage where we're giving patients direct access back to their data. Although, of course, that's part of what our mission is moving forward. We're actually working on pivoting somewhat in the coming years with our foundation to saying, okay, we were able to identify these viruses in a study of, let's say, Alzheimer's brain tissue. Now, what does it take to take that knowledge, take it out of a paper in Nature or Science, right, where it's been published at least, and we know now that it exists, and then say, what are the actual diagnostic tests or the ways we're going to capture that in actual people in a clinic? So that's part of what we're working on now. And that's, again, easier said than done, because a lot of what our focus is now is, okay, let's say we now actually know you have an infection in your tissue. Well, what can we do with your more accessible fluids, your blood, saliva, that we can collect more easily to be able to know that's the case? And so now we're scoping the world for teams with really innovative diagnostic platforms that can capture, let's say, tiny amounts, for example, of a virus, let's say in blood. So for example, there are groups now working on setups where you can use microfluidics to find little extracellular vesicles in someone's blood, and they might have 1 or 2 pieces of the virus that's deep in tissue. But if you have the right technology, you can mine that vesicle and you can get part of that virus, right? But those technology platforms are also interspersed at different labs and with different groups. And so it's a uniting effort to pull the people with that new diagnostic technology together, and then to work to basically design studies, which we're doing now in long COVID. And I can tell you a little bit more. We ended up pivoting into long COVID a lot because we started our foundation not that, like, COVID began pretty soon after we started what we were working on with our foundation. But for example, in long COVID, where people still, in some cases, struggle with the SARS-CoV-2 virus, and I can explain a little bit more about that, we have evidence showing that in some people who have chronic symptoms after COVID, they don't fully clear SARS-CoV-2 from, let's say, the tissue of their gut or other body sites. We're doing a program as proof of concept where we get the tissue from those patients and we can look for the virus in the tissue, but then we get blood, saliva, or other accessible samples, and we send those to labs that have the best possibly new innovative diagnostic test platforms to find little bits of the virus in those samples, and we run those head to head against each other to see how they perform, and then against the ground truth of if the virus is in their tissue. And we start to use that to validate basically how well a test that runs on blood for the virus can be correlated with what it's actually doing deep in someone's tissue. And so there's a lot of stages now to be able to take knowledge of what's happening in tissue and move it into more accessible diagnostic tests.
Yeah, if you could talk a little bit more about the long COVID relationship and perhaps also the one to aging, because I think that it's just crazy. I think once you kind of go down on that path, you just see how everything is so interlinked. And I think you have a really great way to just explaining to even just a layperson, just that like it's not really like these kind of secluded areas of health that we can treat with this one-way approach, but that actually it's a lot more of an organic, interconnected process that we're dealing with, and then hopefully tackling at the root might be harder at the beginning, but hopefully you might also have more resilient systems moving forward. You can really address root causes. So please just share a little bit more about that work.
Yeah, well, before going into long COVID, I guess I would talk a little bit about infection and Alzheimer's disease, because that's what set us up to the way we approach long COVID. So I think one of the lowest hanging fruit and most imminent things that we need to understand, study, and create better diagnostics for is the role of infections as drivers of the Alzheimer's disease process. So there's data for years now that shows that different viruses, for example, some of the herpes viruses, can be found in the Alzheimer's brain. But a guy who was actually one of my mentors named Rob Moyer, who was at Harvard for a while, did what I think was one of the most important discoveries ever around like a little before 2018 or before that. They'd been working on this for a while, but they published a paper in Neuron in the journal in 2018. And it's a paper showing that in Alzheimer's disease, in models that they have, so they have like little brain models or organoid models where it's a mini brain they can do experiments in. And then they also do experiments in mice. They showed that the plaque in the Alzheimer's brain, the amyloid plaque that we blame for the disease process, can actually act as an antimicrobial peptide, which is a basic part of the innate immune response, like one of the most simple parts of the immune system that responds to infection in the human body. And that plaque actually forms in response to infection. So what they did is they took herpes viruses, for example, human herpes virus 6, which a lot of us carry, and again, showed in these models that they could drop a herpes virus in this brain in a dish model and that the amyloid plaque would form right around it, as if it to entrap that virus. And that is essentially the reason that the plaque is forming. So that is huge, because that is a real paradigm shift in Alzheimer's disease, which places infections at the heart of Alzheimer's disease plaque formation. And where that made a huge amount of sense to me is that the current models of Alzheimer's are just not working. If you look out there, for all the billions of dollars that have been put into Alzheimer's research, more people are getting Alzheimer's today than they were last year. So the rates of Alzheimer's are certainly not decreasing, and if anything, going up. And
even adjusting for the fact that people live longer, or
pretty much. I mean, wow. I'm not totally an expert on the rates, but there definitely hasn't been a decrease in Alzheimer's, and there really are the other thing I think is that there are no working therapeutics. So what happened is it's a little like the theory of autoimmunity stymied a lot of the chronic infection work that was on track. In Alzheimer's disease, there became, over the last decades, the plaque itself is bad. So Alzheimer's just became based on this model look, we can get someone's brain with Alzheimer's. We can find this plaque there. That plaque itself is bad. We must remove that plaque, and that will solve the disease. And so based on that idea, many biotech companies, justifiably went in that direction, where they have worked at, there's dozens of them, drugs that have been innovative to remove plaque from the Alzheimer's brain.
You want to remove, but ultimately, ideally, you also want to prevent it from ever occurring, right?
Well, that's true. I agree with you very much. You're coming in on a somewhat late stage of the disease, but still, you would think that if the disease was just based on plaque accumulating is bad, a drug to remove the plaque would help. But when they've run clinical trials of these amyloid removing drugs, they've failed again and again and again. And that one got through recently, but the improvement that it drives is not massive. Whereas if you look at it differently and you say, wait, what if the plaque has a function? What if it is forming for a reason? What if there are factors, for example, infections, that can get into the brain over time in people, and the plaque is forming in response to that infection, and that's why it's being seeded? Then just removing the plaque alone is not enough. You also need to address the infection that is seeding the plaque. And that, to me, is the paradigm shift. If we actually run with that, that will transform Alzheimer's disease. Because, okay, go ahead.
Well,
Yeah.
Could you just prevent that the plaque from ever having to be formed just by preventing from getting infectious disease? It sounds like it's very difficult to prevent you from getting infectious disease. What would one do if one really tried to address it all the way at the root? Does that just mean a very secluded lifestyle, or what can you actually do for that? Is it early testing? Is it just, what's the lesson here? If people are listening to this are quite worried now, reasonably so, about getting infected with anything, what can they do in their day-to-day life?
Yeah. And one thing with the Alzheimer's disease and the plaque is that it's a gradual process. So there's a paper came out recently with Ben Reedhead's group from Arizona State. That's great, because what they did is they got tissue from the vagus nerve, again, that important nerve that connects the brain. It goes right to the gut, for example, and then goes straight into the brain. And what they showed is cytomegalovirus, another herpes virus that once we get those viruses, they persist in our bodies for life. Seems to start out in the gut of people with Alzheimer's disease, then travel up the vagus nerve. So they find it in the tissue of the vagus nerve and use that nerve as a route to the brain where it eventually seeds plaque, right? So you could absolutely intervene earlier with someone so that they either don't get the virus in the first place, which is obvious, or you do something about it and you do something to treat it or mitigate its ability to be active in someone's body really early, and it never goes up the vagus nerve into the brain, and you prevent the disease process, which is, of course, what we really want. And I think that has been, with infection, under-considered the tools that we have that are pretty straightforward to help prevent people from getting more infections. Because I think that in the world of infection, when people start thinking, okay, I don't want an infection, immediately, and this comes up a lot, it's, oh, you have to get a vaccine. And okay, it's possible. We all know that it's an option. Okay. And obviously COVID emphasized, there was a major focus on the vaccine, not as much on other more antivirals or other immunotherapies, for example, to actually address the infection. We had a real focus on that. It's just one tool, and it's never positioned that way. I think one of the clearest things is that, let's say it's a respiratory virus like COVID or flu or RSV or so many, an enterovirus. There are just a good number of viruses that we inhale, okay? What we would do if we just simply cleaned indoor air, and this is one of the things that I really just talk about it enough. If we cleaned indoor air, this is just a simple thing where you can take a room, for example, in a school where there's a bunch of kids sneezing on each other, and everyone knows that they get sick from their kids often. And maximize the HEPA filtration in that room. I mean, the technology now to just pull a virus out of the air with really good HEPA is so much better than it used to be. And there are groups innovating this to just clean out of the air. And also, you can, for example, use far germicidal UVC, which is, at this point, depending on the group, been studied as being fairly safe, where you use a form of UV light to go basically kill viral particles in the air in a room. So if you start to layer these approaches, if you layer really good HEPA with also the germicidal UVC that's killing the viruses from that direction, you can decrease the chances that someone will ever even just breathe in a virus in the first place by a lot. And it's madness we're not doing that. It's madness. For example, we clean our water. I use this as an example. If you go to the tap and you turn it on, you might use a Brita. In fact, people do. This is the interesting thing. People will Brita their water and filter their water, and they really care, right? But you don't go to the tap and expect to still get just some serious infection from your tap water. But we do regularly just walk in a room and totally expect that we might get sick without even taking minimal effort to filter our air, which just doesn't make sense.
Yeah, it was interesting at the conference where I think we last saw each other, the DIA conference in the Bay Area. I think it was, earlier this year. It was interesting because they had filters everywhere.
Exactly.
And it was just, you have to do this for conferences. We're now doing it for many of our foresight conferences, just because if you have so many people in a room, it seems almost like irresponsible to not put a little bit more thought into it. And it's not that expensive. I think that's the point of it. But in general, UVC and air filtration, that both came up, at least in some of the subcultures that we're part of, post-COVID. And I think even some higher up in the government, in more government closed circles, but then has much happened on a kind of national front in that area? Or what do you see as some useful players, when we think about the big one in terms of next pandemics, potentially not being too far out, what can we do on a more perhaps civilization scale to actually incentivize the use of some of these technologies?
It's a really good question, because right now I think what's unfortunate is that the public isn't even demanding cleaner indoor air, and that would be the start, because there's even unfair situations where I'm pretty sure the White House and some of their rooms, for example, have put in some really great UVC systems, and they're cleaning air from everything they're doing with our tax dollars. But the average school doesn't have anything set up, right? And it's unfair, honestly.
I actually talked with someone at the DoD, and they said they just put a bunch of plants next to them because it's actually kind of difficult for them to adjust their workspace as they see fit, because it's very hard to get things in and out of there. But plants are fine.
Maybe plants would help some. Look, plants would help some. I don't know. I think there are, there's a movement with some people who are wealthier to go ahead and put that in their houses or things like that. But the average person is just still out of luck with where they're at. And I think first, because there's been efforts to create more of a movement to just say, let's clean our indoor air. So, for example, there was a meeting at the UN recently, and people committed. There are people from lots of different countries there just saying we should do this, pledging to clean indoor air. But at the same time, to really get movement and to really get at least government proactively involved, or to even get cohesive ways to do this involved, we need the average person to want it too. And I think what's happened is that, understandably, the pandemic burned a lot of people out. And I think that what happened is, because there was such a vaccine-only approach with COVID, because people were mandated what to do, which wasn't a great approach if you ask me, and there was way too much of a push on that front with COVID, a lot of people just ended up, because I see this again when we study long COVID, a lot of people ended up taking the perspective of, okay, forget all of this, right? I just don't want to have to think about viruses anymore. I just don't. We burned people out a lot. And now if you come to them with something way more practical, way more straightforward, where you can go in a room and you don't even have to know these filtration systems are there. You don't have to get injected. You don't have to do anything like that. They're like, oh yeah, maybe, but they're burned out from the fact that they got exhausted with viruses and COVID and a lot of other things like that. So I think what would be helpful is honestly to acknowledge that COVID was not perfect, that there were a lot of things with the COVID pandemic that were not ideal, and that we need to think about that, and we need to think about how we're going to deal with other pandemics or situations like that, but to not think that just because there were things you didn't like about the COVID pandemic that we should now give up on controlling viruses at all. Like those two things can be true at once. The COVID pandemic can have really kind of sucked, and we still have to care about viruses, getting them out of the air, controlling them better in our bodies, understanding the impact they have on diseases like Alzheimer's. We totally still have to do that no matter what.
Yeah, I mean, it's really useful information. I think it's information that many people have probably not received all that much. I wonder from a existential hope lens, because I think at first this information can be very scary.
Yeah.
Just because it might make some people really quite reluctant for entering public spaces, especially if I know that from our community, there is a lot of focus right now from just setting up your personal space and infrastructure and like spaces that people are gathering in the perfect way. And like you can get like really lost in it, I think, to some extent as well, right? Because you're suddenly just like, I need to prevent from getting an infection at all costs.
Right.
But if you think about it from a hopeful lens, if we focus more on like root causes and on like really trying to prevent or cure these conditions once we have them, and especially like the potential benefit for aging too, if you connect that to how can we think about creating a better, healthier civilization in the long term, if one adopted the framework that you're advocating for, like what's in it for people, like from a positive lens, like how could they like reframe the way that we approach healing and health in general as a civilization to be a little bit more resilient in the long-term future?
Yeah, exactly, because people do tell me often that I scare them somewhat by talking about infection and lots of different chronic diseases and infections as drivers of aging processes, which they absolutely do drive inflammation, epigenetic changes that are definitely not ideal as you age. But to me, what is far scarier is an epidemic of chronic disease that we're currently in, where the incidence of most chronic conditions is going up, and kids are getting sicker with diseases at an earlier age, and people are truly in poor health. Many people are taking at least one prescription medication, if not multiple prescription medications. That scares me the most, is that right now, we're definitely not on the right track. Really, the paradigms on which we're basing chronic disease, the models and the root cause drivers that we're thinking are happening, and the treatments, which are largely Band-Aids, are not working. So it's better, in my opinion, to at least consider that infections that can get into our nerves and our tissue could be drivers of some of these chronic diseases, or many of the parts of these chronic diseases, because at least we have more of a problem than to solve. And the truth is that we haven't even tried to approaches that are much more straightforward to curb infection in chronic disease. I mean, there is in Alzheimer's disease a study that was done in Taiwan where they have a national database and they can keep track of thousands of people and their health and the medications that they take. And what they looked at is they looked at people who had taken anti-herpes virus medicines. So if you get a cold sore, you can get a herpes virus medication like Valtrex or Valsite. It's available at every pharmacy. It's a cheap, generic, affordable drug that you can just go get right now. They looked at people who'd been prescribed those anti-herpes virus medicines for that kind of thing, like a cold sore. And then they looked at rates of Alzheimer's disease. And the people who had taken those basic antivirals had a 10 times lower risk of developing Alzheimer's than people who hadn't. And that's really, it makes sense when you look at the data. And
that's incredible. So extrapolate from that example to like globally, like taking this seriously, because you say we're not even trying. If we were trying, let's say in 5 years, what does the world look like in which we're trying?
Yes. I mean, first of all, there are existing drugs like those antivirals that no one's using. You could do as part of a health span protocol. You could rotate in a couple anti-herpes virus medicines here and there probably lower your risk of Alzheimer's truly from simply doing that with these medicines that are well tolerated, not hard to access, cheap. You could just do something simple like that. But also, there are a growing number of companies, and I think this is really the future, or groups that are working on therapies that do not suppress the immune system as drugs, but support the immune system. So, for example, even Pat Soon-Shang in Immunity Bio, if you follow what they're doing, they have a therapy called BioShield that activates a person's T cells and natural killer cells, these key parts of the immune system that can come in and better fight infection. And there's several other groups, many, and there could be way more, that can do really smart things. Take your T cells, make them more active against infection, just straightforward immunotherapies that keep your immune system in a stronger state rather than a weaker state. Because right now, we start people off, like I said, on palliative medicines or immunosuppressive type therapies, sometimes young when they're early in life. And that's crazy. If we even in anyone, even in someone who wasn't sick, considered periods where they went on an immune supporting therapy to keep their T cells active, to keep their natural killer cells active, there's a whole paradigm there where you would simply prevent people from getting more infections or having those infections do things that were detrimental in a huge capacity, just by supporting the immune system instead of shutting it down. So simply just changing our mentality to our immune systems are not our enemies a lot of the time. Truly, they are largely on our sides. Like, why don't we think about that more and help our immune systems help us rather than shutting them down? That simple shift in thinking alone would go so far.
I love that. And that's much on the treatment side, right? So in order to get there, I guess, like we need to improve diagnostics so we can even figure out like that is maybe what's going on. And that's ultimately a lot that you guys are working on at PolyBio. But like, if you think if that work could be replicated, let's say society-wide in 5 years, like, just to get people actually on board with that mindset shift that needs to occur, what are some ways that we can get there? That seems to be almost like the root cause of creating the data sets in the first place and like really waking people up to the fact that could be at stake. So like society-wise, are there any like recommendations that you'd have for different, I guess like how could you scale what you're doing is I guess what I'm asking.
No. We need, at this point, I'll be honest, government to come in more behind this right now. There's private funders and you can up that infrastructure. And I think there's a lot of potential in private funders who can make a huge difference on shifting paradigms. And that's a cool thing to think about. But really, a lot of where science is at is still using government funds to do good projects. And right now, it's extremely hard to get a grant to study the role of persistent infection in a chronic disease, let alone a grant to innovate some kind of treatment like a proactive immunotherapy to do it. It's really hard, for example, in Alzheimer's disease alone, and there's news stories on this. The NIH grant panels ended up having basically a cabal of people, that's what it ended up being called, like a group of people on the grant decision panels who would just shoot down every proposal that came in that positioned infection at the heart of Alzheimer's disease, largely because, that would threaten the other pharmaceutical stuff and the other in-place structures and other therapeutic attempts in the space. And we have to stop that. There cannot be small groups that shut down thinking on infectious disease, which can happen more than is necessary. There cannot be people hanging on to old paradigms. There really has to be a true understanding that this is a very urgent situation, that there are a huge number of infections out there. We have gone through this pandemic that has been pretty messy. And if we want to solve it, we have to be able to fund people who can look at these infections, study them for what they are, and get the funding to do that. I think, so moving that forward, which is basically shifting parts of government's thinking on making this a priority and opening this as an area of research that is not hard to do, is at least a start that doesn't exist as much as it should right now.
And do you see any, I guess, kernels of hope that it's changing or that people are waking up to this? Or is it more, any
Yes, I think there's more recognition now that, again, that we are living in an epidemic of chronic disease, that we do need new solutions. I think more people are thinking along those lines, which is necessary. And I think also that there are enough people who are developing better tools to be able to find infections, and that if we can take advantage of some of the newer tools and diagnostic platforms and actually move some of the better diagnostic tests that don't exist yet for infection forward, which is a big resource right now, then at least we'd have a basis to be able to move forward. So yeah, I am energized more by, I would say, at least with people I know, finally admitting a little bit more that what we're currently doing is not working with chronic disease and that we need new solutions. And also by iterating new technologies into the pathogen identification space that have a lot of potential.
I guess acknowledging that what you're currently doing is not working is the very first tiny step into some positive direction, hopefully, if you learn the right lessons from it. And we have 1 more minute left. Is there anything you wish I had asked that you really would have wanted to tackle?
No, I think that's a good start. Yeah.
Yeah, thank you so much. How can people learn more about your work?
Just go to polybio.org and you can check out our website and here and there some other podcasts or things I've done as well.
Thank you so much. I really think that the message that you're conveying is like kind of hard to swallow at the beginning, but then it does open up like just like a much more richer space to also attack some of the root causes of not just diseases, not just like long-term conditions that we have, even aging. Like it's just like a big bucket that is possible to solve with this as well. So thank you so much for joining us today. And I think you did leave us with a glimmer of hope that with the right approach, we can hopefully get a grip on much of the things that ail us in our day-to-day life. Thank you so much.